Greetings, everyone. We are recording today's broadcast, May 6, 2021, where the Association of Passive Optical LAN and its members are glad to share with you today's topic of questions about wireless. How would a optical LAN connect have anything to do with wireless? Well, it turns out there are a lot of opportunities to evolve and extend wireless technologies using an end-to-end network that involves passive optical LAN. And we're thankful that you have joined us today for our presentation. My name is Mario Blandini, and I'm part of the marketing committee for AppLAN, and I work for DZS in product marketing. And we have a lineup of great speakers. I, your moderator, am happy to also welcome Jeff Van Horn, who is president of Uber Data Networks, a member of AppLAN and on the marketing committee. Also, Pascal Dom. Nokia is a big part of our Association for Passive Optical LAN, and he is a subject matter expert in this area, working for Nokia. And to wrap up today's discussion, Gayla Arundel, who will be discussing her expertise from Corning, who is also a member of the marketing committee here at AppLAN. We'd ask that you ask your questions at any time using the Q&A and or chat. We'll get to those in the end or could sprinkle some in during the broadcast. But what we're trying to do today is give you information in three areas. What are the benefits of passive optical LAN specific to Wi-Fi, AX version 6, the latest and greatest wireless? And I'm sure most folks know that wireless is growing as a share of overall broadband internet connections. There are some considerations for fiber-based network designs and the readiness and best practices of using fiber optics for those 5G deployments. Our guest expert presenters will cover these in that order. And without any further delay, let's go ahead and welcome Mr. Jeff Van Horn, who is a really great expert in this area. I love listening to him talk about these things. And he hails from Columbus, Ohio, where he comes to us today to talk about the benefits of using passive optical LAN for Wi-Fi 6. How you doing today, Jeff?
I'm doing great, Mario. Thank you very much. I appreciate you hosting this for us today, and I appreciate everybody joining us on the webinar.
All right. So talk to us about the benefits of using passive optical LAN for Wi-Fi.
Absolutely. So our company, we're a system integrator. We've been very involved with passive optical LAN technologies for probably about 15 or so years now. We've got a lot of experience in evolving these networks as technology evolves year over year. And so one of the topics that comes up, and we talk to our customer base quite a bit, is what happens with wireless technology as the newer generations come out. So what I want to talk about today, just brief overview of passive optical LAN. Hopefully everybody on the call has a level of background with the technology, but we're really going to focus on Wi-Fi technology and the trends in the newer technologies coming out and how it impacts how we design our networks. And not only how it impacts the fiber networks, but we're going to compare it to how it impacts traditional copper networks. And at the end, we're going to talk about fiber networks or copper networks handle technology transitions better. And I bet all of you can guess where we're going to go with that one based on the topic of this webinar. So let me briefly touch on. There we go. Let me briefly do an overview of passive optical LAN technology. So for those of you, this may be a little bit new. Passive optical LAN uses optical technology not only in the backbone, but also on the horizontal drop side. So we use single mode fiber optics from the main data room all the way to the end location, which also includes what traditionally is from the IDF closet using category copper cable. We use single mode fiber optics. We can also use multi-mode fiber optics in certain conditions. But passive optical LAN, this has been a very emerging technology for the past 15 or so years, and it really aligns with the evolving model of service centralization. So we know our services are primarily migrating to cloud-based services, software as a service, network as a service. About 90% of all data transactions within a corporate network goes up to the data room and most of it out the WAN interface to the cloud. So with passive optical LAN solutions, we introduced the opportunity to run 12 miles. And we know with our traditional networks, we're usually limited to 100 meters with category cabling. And now we have the opportunity to go 12 miles on a passive network instead of being limited to 100 meters. We are also able to eliminate IDF closets. And that's kind of a new concept. And we talk to a lot of our customers in the traditional networking world. But given the distance and the fact that we are all passive, we can eliminate IDF closets in many cases. And really what we're going to focus on today is how do we transition specifically wireless technologies without impacting the infrastructure in our building. So we'll talk about, for the past many years ago, deploying gigabit Ethernet over GPON technology. Now we're deploying multi-rate interfaces over XGS-PON, 10 gig technologies where we're handing off 2.5, 5 gig, 10 gig interfaces to some of these newer devices. And we have 25 gig and 40 gig technologies coming out in the future. So we'll touch on how do all of these technologies benefit our customers, which is the most important piece. So when we look at trends, especially in wireless, wireless it came out in the mid 90s and it's ubiquitous now. But for years, everybody has been talking about everything is going wireless. We're going to cut the cord and everything is going to go wireless. And, I refer back to the good old days, and really the low voltage contractors talk about the good old days when Ethernet ports were in abundance. And when we look at the BICSI specifications, we're running 4 data ports to every single office. We've got a port for data, voice over IP, printers, even legacy ports for things like modems. Training rooms had multiple ports per student seat, conference rooms, print rooms. So at the end of the day, we have these buildings with a tremendous amount of copper cables, and the low voltage contractors call these the good old days because that was the heyday of making a lot of money putting copper networks in. Well, over the years, wireless technology has become much more efficient, much more secure, and also, of course, faster. And business connectivity is trending towards wireless connectivity. And it's a trend that is truly going to continue to evolve in the future. Now, there are some portions of technology in commercial buildings that are kind of holdouts that it's not ubiquitous, things like point of sale terminals that have PCI compliance, security cameras that have very high availability needs, fire safety, of course. Those are transitioning to wireless over time. Those are what I call holdouts right now. But at the end of the day, these services are going to eventually transition to wireless. And when we look at the reduced number of cable counts within a building, it doesn't make the network easier. You think since we're removing ports, it makes the network easier. It does just the opposite because now we have more requirements and things like speed, security, and flexibility. So I want to go back and review the different wireless standards for Wi-Fi. And what we notice when we look at the standards evolving over the years, wireless is typically on right around a 5-year refresh cycle. So with our customer base, we typically refresh our customers' wireless networks about every 5 years. And when we go back and look at the standards with Wi-Fi 4, and for you techie types, that's the 802.11n technology, which was referred to now as Wi-Fi 4, primarily operated on the 2.4 gigahertz spectrum, had the ability to run on the 5 gigahertz, really didn't too much. That was in 2008 when it was ratified, and it came out shortly thereafter. Wi-Fi 5, which was AC 82.11 AC, Wave 2, was introduced in 2014, provided a significant increase in speed, operated primarily on the 5 gigahertz spectrum, but we saw a big jump in bandwidth in theoretically approaching 7 gigabits per second of throughput. Of course, as a given maximum channelization usage and testing in a lab and things that we really don't see in the field, but it represented a very big jump in bandwidth, primarily because of the use of the 5 gigahertz spectrum. And so now today what we're deploying, and we have been deploying for about the past 9 months or so, is Wi-Fi 6. And Wi-Fi 6 was ratified in 2019. It takes some time for the vendors to come out with their products. But Wi-Fi 6 now is approaching 10 gigabits per second. And it introduces a new spectrum up in the 6 gigahertz range that there's an extended version of Wi-Fi 6 that will come out here in the future called Wi-Fi 6E for extended, but it introduces a new frequency band up in 6 gigahertz that really allows us to increase the speed up to nearly 10 gigabits per second. Now, that 10 gigabits per second is kind of a magic number because that is the upper limit of speed available on a Cat6a cable. We'll touch on that a little bit later. And so in the future, we're looking at Wi-Fi 7 and beyond, and Wi-Fi 7 takes yet another large leap. There's a lot of spectrum available up in 6 gigahertz. We're going to be running, they claim 20 to 30 gigabits per second out of an access point. So big jumps in technology there. But as you notice with the dates, everything is on essentially a 5-year refresh cycle. And interestingly enough, that aligns with the refresh cycle of many of the major Ethernet switch manufacturers, where they become end of support over time. And not only do you upgrade your wireless network, but then we have to look at how do we upgrade our access network, our distribution, our core network. What impact does it have? Does this require a copper category cabling refresh from Cat 6 to Cat 6a to accommodate for those higher speeds? What we'll talk about throughout the next couple of slides is for those customers lucky enough to be using single mode fiber and passive optical LAN solutions, no cable refreshes are required to support that. So let's take a look at what wireless does to our network, because it does have a big impact on how we design our networks. So with every release of a new wireless technology, we deliver higher bandwidth per access point, and that's a given. We just looked at that on the previous slide. But with the higher speeds, creates a smaller serving area. So when we are reducing the serving areas to get the higher speeds, that's because we have higher channel widths on the spectrum, higher frequencies that don't propagate walls and obstacles very well. We have higher levels of modulation, which requires a stronger signal. So you have to be closer to the AP. FCC limits maximum output power. So for all these reasons, every generation technology requires the access points to be placed closer together to provide seamless high-speed delivery to all of our services. What that means for the network is we now have a lot more access points that we have to deal with. We have a very, very high density up in the ceiling for these wireless access points. And so not only are the access points delivering more bandwidth on the air, but we also have to deliver bandwidth to the access point. And that is, and so when we look at Wi-Fi 5, we were delivering gigabit Ethernet, one gigabit per second, sometimes multiple Ethernets in a link aggregation group. That wasn't very common, but we were delivering gigabit Ethernet. With Wi-Fi 6, we're approaching the 5 to 6 gigabit range, could get up to 10 with extended. And now we're looking at Cat 6a. And Cat 6a has an upper limit of 10 gigabits per second over the given 100-meter distance limit. So the big question is, what do we do when Wi-Fi 7 comes out and we have 20 to 30 gigabits per second capacity on an access point? We have to get a cable to the wireless access point to support those speeds. Well, with Cat 6a is the end of the line for copper technology and the local area network as we know it with RJ45 connectors. And so the next step when we get to Wi-Fi 7, we're going to be looking at single mode fiber is the answer and many times the only choice for connectivity and beyond. So what is very important for the system integrators and the folks that design these wireless networks is the placement is very critical. You know, there always seems to be when you're trying to fill in dead spots, right? When we use these higher frequencies, there's a lot of dead spots because they don't propagate through walls too well. And it seems like when we're adding wireless access points to fill in the dead spots, we always end up over that 100-meter distance limit of a category cable. And that becomes very difficult. Now we have to put in new switches, new closets, things like that. Passive optical LAN makes it very easy because remember, we have a 12-mile distance limit now and not a 100-meter distance limit. So the flexibility that we get by using single mode fiber and passive optical LAN allows us to better accommodate the challenges that we run into with these higher speeds of wireless technologies. So one way to look at this just graphically from a cable plant, what does this do to our cable plant primarily above the ceiling? So when we look at what happens within our infrastructure and our building using fiber, is we see that the pathways are very efficient, they're very small. And the one reason for that is the optical network terminals, and that is the device that turns the fiber back into the gigabit Ethernet, the 10 gigabit Ethernet interfaces. We have multiple ports on those ONTs. So we're going to run one very small diameter fiber optic cable to that ONT. And that ONT comes in 4-port versions, 8-port, 2-port, depending on the model. We are getting multiple Ethernet ports off of an ONT, meaning we can connect multiple access points and other devices above the ceiling with a single piece of fiber. And fiber optic cabling has an outside diameter of right around 0.2 inches, so it's very small. So when we contrast that to what we've traditionally been doing with a active Ethernet switch network and category cabling, is now we have a 1-for-1 ratio. So every access point requires a single copper cable. And these copper cables get larger with each generation. So Cat6A is up to 0.35 inches of outside diameter, about twice the size of fiber. When you look at the overall area, it's about 4 times the size. And we have one cable per access point. So when we look at what happens up in the ceiling, we're adding more and more access points, which means we're adding more and more category cables, and these cables keep getting larger. So we have to think about things, what happens to the ladder tray and the penetrations on firewalls and things like that. It has a very large impact up above the ceiling, and it's a big challenge in a traditional sense when we're using fiber optics due to how small they are. And of course, we get 12 miles of distance instead of 295 feet. It gives us a lot of flexibility to not only have easier connectivity, but mind you, we're running fiber optics that runs over 100 terabits per second today on the medium itself. So when we look at future proof, we're running tremendous speeds and have the capability to run tremendous speeds on a very small form factor type of cable infrastructure. So when you look at this, what would you rather put above your ceiling? How would you like to future-proof your facility for these evolving technology standards? Would you rather put something small, flat, and very fast, or a technology that's outdated, that's very hard to work with and only growing in size? And by the way, Cat6A is the last copper standard for 100-meter LAN with RJ45 connectors, which is our standard process today. So how do we cope with this? How do we when we're forced to deal with this, how do we cope with it? And what does this do to our customers? So for those customers lucky enough to be running on optical LAN with fiber optics, there's no change to the infrastructure. And we'll talk about the concept of coexistence in a few minutes, but we're able to run multiple generations of this technology over the exact same piece of fiber. And that's because we use wave division multiplexing technology. So when we upgrade to newer, faster speeds of PON technology to account for faster wireless speeds, we don't have to change the fiber infrastructure. The only thing that changes is the ONT model at the end. And these ONT models, again, come in multiple configurations. Many of those configurations include multi-rate ports for connecting to these higher speed devices, where we can run at 2.5 gig, 5 gig, 10 gig Ethernet to those devices. There are even SFP models that are ONTs that allow us to operate on GPON and 10 gig GPON speeds. On our next slide, we'll talk a little bit about coexistence, but when we look at the technologies of PON where we're deploying 10 gig symmetrical PON, which is called XGS PON today, we have NG-PON 2 that's available. We have 25 gig PON in definition, 40 gig PON. So all of these versions of standards in the future will coexist on the same fiber infrastructure. So when we compare that to what we've been doing for 25 years with active Ethernet infrastructure, with copper is now we need to take a look, do these increased speeds affect my core switch? Now, do we need to look at the distribution switches depending on the size of the facility? And of course, we have to look at the access switches, because the access switches will need to be replaced with multi-rate access switches. And now we're going to multi-rate. Well, do we have Cat 6A in our building already, or do we need to do a cable refresh? So when you look at all of this, many times you're looking at primarily a forklift of your network. We're replacing the equipment, we're replacing the fiber infrastructure, and making these changes to a traditional network. Of course, that leads to downtime. All these upgrades lead to downtime. If we're going to replace the cabling, we're looking at downtime of weeks per area. Significant planning cycles, budgeting cycles, multiple vendors, a lot of coordination that's required. Of course, there's a loss of productivity. And anytime we make changes to the network of that magnitude, we introduce the opportunity for human error, which is always there. So the more changes that we make to a network, we're going to lose money. And not only do we lose money and productivity, but it costs money to make these changes. So that really is one of the big benefits of the passive optical LAN technology is we're able to coexist all of the future generations of technology. Remember, fiber optics, single web fiber optics has a lifespan of 30 to 50 years. So when we're able to run GPON technology from that's been around for many, many years to 10 gig XGS-PON technology that came out about a year and a half ago, to the future PON technologies, everything runs on individual wavelengths. And so when we look at the main data room here, we'll have multiple versions of this technology, of the PON technology coming in. We simply combine it with a passive optical combiner. It's a CWDM combiner. That puts all the wavelengths on a single piece of glass. And we plug that into our existing fiber infrastructure in the building. So we have not impacted the fiber at all. When we get to our existing passive optical splitters, it splits all the wavelengths evenly. When we get to the endpoint on the ONT, this is where the upgrade occurs. We're not going to change the fiber infrastructure, but the ONT, if we need a new speed and a different interface to our 10 gig wireless access point, we simply replace that ONT. These ONTs are based on specific technologies, and they only pick up the wavelengths that they are programmed to pick up. So a GPON ONT will only pick up the 1410 nanometer wavelength in the downstream. The XGS-PON ONT will pick up its wavelength, and the future 25 and 40 gig PON ONTs will pick theirs up accordingly. So we can go through at the endpoint and just do an upgrade only where that interface is required, because all of these technologies simultaneously operate on the same fiber infrastructure. Up in the main data room on the OLT side, the OLTs will require an equipment upgrade, of course, to provide the new fiber optic speed out of the OLT. Sometimes that means putting in a new OLT adjacent to the existing. There are many equipment vendors that have OLTs that operate multiple generations of technology based on only the SFP plus module that you plug into it. So changing from GPON to XGS-PON is simply a matter of swapping an SFP on your existing OLT. So there's a lot of flexibility there, but the key is we evolve technology within our building. That one of the largest impacts is the cable infrastructure. When we're using copper, it's guaranteed that we have to refresh. When we're using fiber, we don't need to refresh. And that is one of the takeaways that I hope you take away from this presentation. Is that is one of the biggest benefits long-term is a fiber infrastructure lasts 30 to 50 years, and the concept of a cable refresh doesn't exist with passive optical LAN. So in summary, when we look at what we've talked about, single mode fiber optics cabling is part of the TIA standard. It is the next generation local area networking technology. Passive optical LAN solutions offer the speed, flexibility, and the future-proof capability for next generation network. So the wired network may be dead, but it doesn't mean that it's any easier for us designing networks. Everything primarily is living above the ceiling these days. So thank you very much for your time today, and we will pass it on to Pascal at Nokia.
Thank you very much, Jeff. And I welcome from Brussels, Belgium, Pascal Dom. It's his afternoon, and we're probably keeping him from a nice Belgian beer beverage to enjoy his evening. But thanks, Pascal. Talk about some of the considerations that are good to consider when designing fiber-based networks to support these wireless use cases.
Yes, thank you, Mario. And thanks for having me at this opportunity to give the presentation to the passive optical LAN community here. Within Nokia, we are indeed looking a lot to this combination of wireless and the passive optical LAN, and creating not only the Wi-Fi, but also looking to the whole evolution to a 5G era, which is for us more a combination of Wi-Fi and the different wireless nodes. So in the first couple of slides, I want to explain to you what we mean by this in-venue wireless solution. So what do we have to design as a network to create an efficient backhaul solution in venue that could support all the wireless techniques, Wi-Fi techniques, but also be ready for 5G networks that would be installed on the same fiber infrastructure. Now, first, I think one of the interesting points we are discovering in this, I would say even current days of deployments is the fiberization of the venues is taking place. So we heard from the previous speaking a lot of reasons why this copper cabling is now being reused or replaced by a fiber infrastructure. We do think that the fiberization of these venues will continue to even as close as possible to the workplace, and if we're talking about wireless, to the wireless access point. So the venue as a concept is also a much broader than initially we saw for our passive optical LAN solutions, because we are now also considering these campus solutions. Campus solutions, as you see a picture here on the top left, we do see there a picture of, for instance, one of our Nokia radio access points that are delivering a service, a wireless service for an outside deployment. Of course, on the bottom, the traditional in-building solutions, both Wi-Fi and 5G radio. And at the same time, we see now a change happening into not only the office LAN that was traditionally the area of passive optical LAN, but we are also seeing a demand coming up in the industry for production networks. Production networks and office networks are not the same, and with and in some cases even they are, for security reasons, they are in parallel. But on the end, it would be good to have a fiber solution in both cases, and especially when thinking about the robots in production networks, we do see that they are connected through a last few meters as a wireless connection. So the in-venue is now becoming a campus that can be indoor and outdoor locations. The typical example, think about the airport that's shown here. In these areas, you'll see that there are the terminal buildings with the passenger information, but also with all the access control, etc. But also in the outdoor, which includes some of the cargo, also includes some of the movements of the different airplanes on the grounds of the airport. So the whole concept of a passive optical LAN becomes not only important inside as an indoor environment, but also in a full campus outdoor environment. Another typical case is the event venues. So we can imagine the more bigger stadium can go from concerts to sports events. But you can also imagine a number of other cases where This is a little bit broader than just an indoor solution. Sometimes a typical example would be for instance, the Olympic Games with all the villages, etc. So all these cases, fiber becomes more and more important as the carrier for the transmission, both indoor and outdoor, because as the reasons are listed at the right-hand side here, we have both, of course, the cost of the cable itself, the fiber cable versus the category 5, 6, etc. cables is completely different. But also, and that was clearly explained by Jeff just before me, these unlimited bandwidth aspects that we see with fiber clearly shows that this gives you an opportunity where the copper cables will no longer be able to follow. Other things that are coming up, and then I'm pretty much referring also to this production network, the industrial Internet of Things, if you want. There's a need to have some fire resistance, and apparently copper cables have a shorter resistance. Of course, in the end, with a calamity like a fire, it can destroy everything, but the fiber network will give you some longer fire resistance, which will make it more applicable in these industrial networks. And also, and this is becoming important if you go to these wireless connected robots. In that case, we do see that the disturbance of these machines on the wireless connection, which is under control, but also on the copper cables, if you would still use them, gives you an electromagnetic disturbance on the specific machines. And therefore, we do see the need to have fiber to the workplace in these particular cases. If you look at this now from a cost point of view, the main reason that we see is, and I'm sure this repeats a little bit what Jeff was saying, but in the comparison between a copper-based network that we all know now to a passive optical LAN, of course, the complexity and the power savings we can do with an optical cable include some of the indirect cases. So for instance, when you have an IT room or an IT cabinet every 100 meters, 180 meters, it will require you to also have the different HVAC or fire suppression, also the copper MDFs. They all are needed at these locations, which gives you an important both capital as well as operational costs that are associated with these IT rooms. While if you go for passive optical LAN, of course, in that case, you will have still the OLT located in some IT room, but the IT room becomes more like a public or the private data center environment where some of the more advanced cloud-based services could be hosted. On top of that, we discussed the end of the category 5, 6, 7 cables or with gigabit support, while we see now with the fiber, and if you look then to the Wi-Fi requirements, but also, and this is very much applicable today in private wireless with both the 4G LTE and 5G new radio deployments, there is a need that goes beyond the gigabit area. And then we are with fiber for sure much more future-proof, because there the fiber investment will give you the terabit support, as we would call it. So it's about an order of magnitude. We say unlimited, but you can also imagine 1,000 times more capability with a single fiber than a copper cable. On top of that, and this becomes an important reason to change from copper to fiber, is that the overall cost, and specifically the cost of maintenance, becomes extremely high. if you continue with copper cables. And remember what I tried to explain in the previous slide, where we said, okay, these campus networks are much broader than just some indoor venue. It becomes a combination of outdoor and indoor. So the size of these networks are growing. And of course, the maintenance cost associated to that is also growing. We heard before, it's now 12 miles, 20 kilometers that we can reach with a passive optical LAN. So this gives you now an area a coverage area to operate, which is much broader than what you could have done with the different copper solutions. So the maintenance contracts associated to these copper networks are quite expensive. And this is another reason to change into the passive optical LAN as a carrier for all the wireless access point connectivities. What is an important point is that, and here we see the difference, for instance, between using point-to-point cables versus point-to-multipoint or PON passive optical LAN type of solutions. That is that you do have multiple ways of sharing these same fiber infrastructure. So the single fiber that is used in a passive optical LAN can be regarded for the different services depending on the choice of the network builders, how they can combine the network. So what we see is in some cases, think about production networks, it is interesting to have a dedicated fibers just for the wireless connections. This ensures that this network may not be connected to the internet. As such, the network is completely shielded from security reasons. That is very important in production networks from the other office LAN applications. But still, in that case, it becomes very interesting to use point-to-multipoint fibers and use a pole OLT with different access points rather than having coax, copper, or point-to-point fibers connected all over the net, all over the venue. So even in a dedicated deployment, it may be very cost-effective to have an OLT dedicated for the wireless access point connections as represented on the cartoon on the left. On the right-hand side, there is another idea that's popping up. And that's indeed, we could converge all traffic on the same passive optical LAN OLT, which will give you the possibility to mix the traffic and give you a better use of the bandwidth available. Because we have the necessary security, we can add some extra security protection. This will give you resiliency. These are perfectly fitting production network. And the new trend that we are now observing is also to virtually separate production from office LAN networks. So in order to secure the separation or segregation between the traffic types, you can converge everything, but then the next trend in the industry will be virtually slicing, as it's called, virtually separating the access node. In the middle, that's, I have the impression, often forgotten way of working, and I'm very glad that Jeff was stressing on this point too. So POL is one of the own technologies where you really do not need to upgrade the fiber or the cabling system. You can just coexist on a single fiber. So one POL technology, like using GPON, you can use that GPON still for a long time with a gigabit, is traditional office LAN and maybe some Wi-Fi 5 connections that still will be there. But once you say, okay, we will upgrade or we will combine it with a production network, you have the opportunity to coexist on the same fiber, another POL OLT. So one OLT would be dedicated for the production network, and another royalty would be dedicated to the IT network, but still using one single passive fiber network. This can also be important if you really want to separate the wireless connections from some of the fixed access that are already installed, but without having to go to the trouble of deploying new cables. So this coexisting option, very unique to the this wavelength division multiplexing, as it's called, use with PON, is something you can have with these pulse solutions, while the others, dedicated fibers and converged, are also possible. So this just adds to your toolkit when deploying passive optical LAN. One too fasting. So another point, and this is something we have seen only the last couple of quarters, I would say, the importance to have, especially in this outdoor part of the venues, in order to have that as compact as possible. So bringing fiber to the workplace, but especially fiber to the access point. You can work with an ONT with different wireless access point connected to it, or and this is what we see now as attracting a lot of attention, is if we can integrate this optical network termination function, the ONT function, on a pluggable device on the SFP. And this gives us the opportunity to really plug in the whole termination point inside another device. In the picture you see it's plugged in directly into a radio solution. So it's a Wi-Fi or even a 5G radio. It could also plug in directly in a machine or some of the PLC functions in production networks. So this is really a zero extra footprint because the cage is there and you plug in the fiber directly with the ONT function into the end device. Moreover, it requires no extra power because it draws the power from the host device. So you don't need to consider how to bring a power supply to that particular ONT function. It really is drawing the power from the device, and as such, having no extra requirements. But although it's zero footprint and zero power, it still has a lot of packet functions or operation, administration, and maintenance functions. So with the passive optical LAN, we have the opportunity to do all what is called the PON-MAC functionality, medium access control functionality. Think about forward error correction, but also, and in production networks, this is a key feature, it includes a standard for encryption. So this is link encryption, giving you, even if end-to-end encryption on the link is on the connectivity is used, the specific on a hop-by-hop case, you can still do encryption on the pole segment. Of course, when plugging this in a host device, it's an opportunity with with passive optical LAN to give management through the OLT using a standard OMCI feature. So the management function can be remote visibility of this ONT, although it is plugged in directly into the workstation. And last but not least, especially with the wireless access points, and then we talk about the 5G world, there is a need to have a good time distribution, accurate time distribution across all access points, wireless access points. And also there, the POL devices have the opportunity to have a 1588, as it's called, standard time accurate deployment, even over a passive optical LAN, which is normally not used for this 1588, but the techniques to enable 1588 over an asymmetrical passive optical LAN are included in these pluggable devices. So the ONTs become really accessible for outdoor. Of course, this can be also deployed indoor, fiber to the workplace. So in conclusion, I would say that what we see, of course, passive optical LAN technology using PON is actually an opportunity to make power savings. So it's a lot, we see up to 40% power savings are visible in the networks we deploy. We have explained that you can also have the TCO savings. Think about less maintenance, etc. So you can almost half your TCO cost there. But also because of saving of this floor space is especially important also in the IT rooms where we see the need to go with new cloud-based applications in the IT environment. So I now pass the word to Gela for the part of.
All right, cool. Well, thank you, Pascal, for that information. And wrapping up today's discussion, talking about some best practices and getting ready for 5G is Gela Arundel, who is just down the road from me. I'm in Dallas, Texas, and she is in Austin. Thanks a lot for joining us today, Gela. How are you doing?
Hi, thank you very much for having me. Today I'll talk a little bit more on the cellular side and the 5G readiness and using some best practices with fiber optic cabling. Let's see if I can get to my next screen. So I'll just talk a little bit about why cellular and 5G and how we can solve cellular with fiber, and then how we could converge that cellular on an optical LAN. So first and foremost, right now we know, but according to Cisco, by 2023, there'll be 30 billion connected devices and 45% of those will be mobile. And about 80% of all the mobile usage is indoors. So with wireless being everywhere, we really are seeing more and more people looking to solve their in-building wireless coverage inside of their buildings. Most enterprise locations are moving to what we call a universal wireless model, where both Wi-Fi and cellular are equally important and coexist in the building. Wi-Fi is generally used for the data and cellular for voice and for emergency notifications, which both don't really work very well over the Wi-Fi network. So hence you need both Wi-Fi and cellular in your building. According to a Deloitte study from last year, 86% of networking executives believe that advanced wireless, including 5G and Wi-Fi 6, will transform their organization within 3 years and create a significant competitive advantage for their company for years to come. So the path to this 5G has started, but some might ask, what does 5G even mean in the first place? 5G is the 5th generation of cellular networks, building on technology that's been around since the very first cellular network was launched in 1983. The first 3 generations were designed mainly to cater to voice and text, with data transmission then being measured in kilobytes per second. With 4G, that was really designed to support the rising data usage with things like video gaming, etc. And in that case, the data transmission was now kind of up to like megabytes per second. With 5G, this is really being developed to address the rapidly rising levels of data consumption across the globe. The ultimate goal of 5G is to achieve cellular connectivity on par with fixed line service that you get at home or at work. This means gigabyte per second connectivity from your mobile device. So there are 3 main benefits that you'll get from 5G. The first one is enhanced capacity. With all this more data that we have for applications such as the 3D video, AR and VR on our mobile devices, the capacity of the cellular network needs to expand to carry all that data. The second is massive connectivity. 5G will connect not just your phone, it will connect all the emerging IoT devices, everything from your smart fridge to self-driving cars, and even the robotic equipment on the factory floor, like we just heard about. Lastly, 5G will deliver very low latency. Latency is simply the round trip time between two systems. The lower the latency, the faster the results. Imagine an industrial automation scenario with a very high density of sensors and controllers and devices like these robots that require very low latency to operate the manufacturing line at a peak effectiveness. That's some of the ultra reliability and low latency that 5G will deliver. Oops. So with that, we see that 5G is really going to drive the demand on the network. First and foremost, just to get this out the way, 4G anchors 5G in the non-standalone deployment method. So really and truly, both will coexist for some time. The bandwidth requirements that we're seeing for 5G are significantly higher, as much as to really deliver that 10 times more faster speeds and that much lower latency. So the fiber, with its virtually unlimited bandwidth, its lower attenuation, and the immunity to those electromagnetic interference will really be needed for 5G. So 5G needs fiber, and actually it needs a lot of it. So let's focus a little bit now on how we solve cellular inside the building. So not all buildings are alike. The type of solution that you would choose will depend on several factors, one being the number of wireless providers that you need coverage for in your building, as well as the size and type of building. So with that, there are a couple of solutions on the market today. One being small cells, which are really focused in on that small to mid-sized building where one or two operators are needed. And then there's also the distributed antenna systems, which are really typically multi-carrier for much larger buildings and public venues. We're also seeing some of the 5G small cells in these larger venues as well. So there's an overlap there for sure, but you really should choose the solution that fits just right for your scenario. So just taking a little bit of a look now on how you would look at a distributed antenna system fed with fiber to the edge, as we call it. DAS systems support all carriers, and they provide more capacity with better coverage. The DAS distribution is typically technology agnostic, depending on your bands on your radio, so they can do 3G, 4G, or 5G. But if you think about a future-ready fiber DAS network fed by fiber-fed remote antenna units, as you see in this diagram, that really will reduce the cost with taking up less space and less energy, and also give you this future readiness so that you'll be ready for 5G and beyond. The next solution out there are small cells, and I'm going to show you how the benefits of putting small cells on an optical LAN network. So small cells are actually an extension of the carrier's network. They are part of their RAN or radio access network. They typically operate on an IP-based LAN, making them simple to install, commission, and operate. The most popular small cells on the market have been the 4G LTE small cells, but more recently we're seeing the fiber-fed 5G millimeter wave small cells have now also become available. So using an optical LAN network to feed these small cells will really help you to support the building and make sure it's future ready for both 4G and 5G and beyond. So fiber to the edge devices need not only bandwidth. One may ask, well, how do you power these devices? So hybrid or composite cable combined with remote power supply units can deliver 56-volt DC power in accordance with the NEC Article 725 to the edge devices. These type of cables are also suitable for digital electricity, as well as even the 190-volt DC installations in accordance with the NEC Article 830.15. Composite cable is typically much smaller and lighter than traditional copper category and coax cable. And of course, with the fiber, it can deliver virtually unlimited bandwidth at that very low latency. So wire it once and enable everything. So optical fiber networks using composite fiber and power to the edge in a zoned type of architecture like you see in this diagram can deliver the bandwidth and the power needed to support both wireless, cellular and Wi-Fi, as well as all the various wired type of devices that you have out there, be it security, audiovisual, LED lighting, or your typical local area networks on one converged fiber to the edge type of installation. Let's look at an example. When Texas A&M upgraded their Kyle Field Stadium, they wanted a state-of-the-art facility that would rival an NFL stadium and set them apart from other college programs. They wanted the fan experience to be very robust and needed a network to support just that. So instead of having separate copper networks for Wi-Fi, DAS, and their IPTV type of applications, they chose a single optical network with the capacity to carry the traffic of all three. This converged network was ultimately cheaper to deploy and utilized far less space than three separate networks, and today continues to deliver better performance with far more capacity, and it is ready for whatever the future technology will bring. So to sum it up, a converged fiber and power to the edge network provides savings, flexibility, and efficiency. It has more capability and is ready for 5G, Wi-Fi 6, IoT, and beyond, with savings of up to 50% with the infrastructure already in place for future technology upgrades. It costs less, is simpler to deploy, and is much more sustainable, requiring less power and ultimately significantly less space, both in the network closets, the cable, as well as cable trays. Fiber and power to the edge allows for a future-ready, sustainable, and cost-effective way to solve both your wired and wireless applications in a building. So with that, I think we have just maybe a couple minutes, but we're open for some Q&A. Or Mario, shall I hand it back over to you?
Indeed, I'll take it from here. And thanks, Jeff, Pascal, and Gayla for your presentation. We realize we're close to the top of the hour. We'll send out the recording replay to everyone who has registered after the event. But let's go ahead and take some questions while we have everybody. You mentioned power, Gayla, and maybe we'll get a chance for everybody to mention it. There were a couple of questions that came in around power. And so the converged cabling, Gayla, makes sense in that the fiber goes along with the power cable at the same time. But in cases where you may be just using single mode fiber, how do folks think about designing power to the wireless access points or the radio units?
So I could take some, I mean, we showed the way of doing it using the composite cable, which will centralize the power and also power your device using, ultimately at the end, it's PoE that's being delivered from the ONTs.
Correct.
If you're just using fiber, you can use a separate copper power cable, with the remote power as well. Or you can do a local power solution with a typical sort of, more of an AC power. There are other types of powering options outside, like digital electricity, that I wouldn't get into. But I mean, you have a lot of flexibility to do it both remotely as well as locally if needed. And I think Pascal even showed you one where with that new sort of transceiver type of solution, it'll even receive the power from the device itself,
Indeed. Hey, well, maybe this is a question for you then, Jeff, because both you and Pascal talked about converged networks. You don't have to go all in on passive optical LAN. You can operate and evolve your network as such. But overall, even if if you're not using composite cabling, the total number of cables is, especially from a wireless perspective, much smaller because we're no longer running individual PoE cables to every device, but rather just to the access point, making the overall amount of cabling much smaller and contributing a lot to the sustainability and lower cost.
Yeah, Marian, this is Jeff. Let me add a little bit to that from a system integrator perspective. We use the concept of remote powering very, very common these days with passive optical LAN technology, where, as Gala mentioned, there's hybrid composite cables that run the fiber and a conductor pair, if it's 20 gauge or 18 gauge copper pair in the same cable. And so that provides power to the ONT, obviously, along with the fiber provides the signals. Those ONTs all support PoE, PoE Plus, and the newer version support 4P PoE for 60 watt and 90 watt PoE delivery to the endpoint. So when we're looking at converging our networks using class 2 remote power circuits to the ONTs, it's a very natural extension as we do fiber fed DAS, as Gala mentioned, using the exact same power infrastructure along with the composite cabling. It makes for a very common converged fiber optic network with the class 2 powering.
And folks who haven't seen it, I believe there have been several webcasts in the past from the Association of Passive Optical LAN that go directly and exclusively into this area of powering. So thanks, folks, for those questions about power. Another question that we received is about interoperability, the idea, or at least the view that unlike common Ethernet infrastructure, that optical networking infrastructure may not have the same any manufacturer to any manufacturer unlimited number of combinations. And so from my point of view as a company that makes that infrastructure, it's an important question to ask when considering the different vendors that are available there. There are standards-based solutions, and if you haven't checked it out recently, you'll find that over the past couple of years, the flexibility of connecting the ONTs or the end devices to the OLT in the center or in the core, that you are able to mix and match some combination of vendors. It's not as plug and play as you might imagine with classic Ethernet infrastructure, but there is more flexibility today. And the Association of Passive Optical LAN is a big supporter of the idea of us working as an industry to make sure that we're delivering those capabilities to folks as well. We have a question about 1588 V2 scenario when connecting cell sites. The question is looking for a little bit more information on that. And can we use the same clock or different mobile operator? Can we use the same clock of a different mobile operator in this scenario? Is that something you can take, Gala, or Jeff?
I can at least on the 1588 V2. So very specific on 1588 V2 is that you need symmetry in the delay, which means the response mechanism of 1588 will give you a problem if the delay in the upstream is different than in the downstream, which is actually the case with most POL systems. Luckily, what we have seen is that these standards for GPON and also XGS-PON and the new higher speed PON standards, they include an interworking mechanism between OLT and ONT to accurately deliver the time information from the OLT to all ONTs. And the ONT can then it is the master function of the 1588. It will actually talk 1588 to the receiving device. And as such, you will have an opportunity to transport 1588 over passive optical LAN. And then the question associated to that, where will the 1588 be the origin? Can it be from the mobile operator? In some cases, the mobile operators deliver indeed the 1588 signal to the OLT. Otherwise, we see a lot that in a certain area for the OLT is connected to a GPS or other GNSS receiver that delivers a 1588 grandmaster signal to the OLT, and the OLT then distributes the time in an accurate way to all different endpoints. And this will give you the opportunity to really have a time alignment that is matching all standards from the mobile world, but also from new, what is called time-sensitive networking in the industry domain.
Thanks, Pascal. And also something you mentioned in our internal chat here is that there is demonstrated interop between vendors in the standard. And what you may find is that there may be some management features that would be unavailable in the multi-vendor scenario where a vendor could provide some value add from a management perspective, given the same vendor end to end. But these are great considerations when you're going to design these networks to look at those things. We had another question about power. In the end, how does a fiber cable overcome the power for a device at the end? And it's either through these remote power solutions that were discussed or composite cable. But we encourage anyone looking for more information to look at some of the past content that we have in this area, which goes into more detail about remote power. Here's another question about the ONTs and they themselves providing Wi-Fi 6. So Jeff, you mentioned that there are a lot of different services that can be delivered by an ONT on the optical side, but you're probably familiar with designing networks where the ONTs themselves are offering enterprise-grade Wi-Fi 6, if not today, but on the roadmap across multiple vendors, such that it is really a multifunction device. Maybe you can give a little more color about that question.
Yeah, that is definitely a trend that we're seeing within the manufacturer community. Traditionally, we address wireless through typically the main wireless players that have been out there for years, and we're now seeing a lot of the manufacturers of the passive optical LAN equipment move into that space in the past year or so, where we now have options with Wi-Fi 6, enterprise-grade controller-based wireless technology inside of the ONTs themselves. So, and that just provides us a lot more flexibility on deployment and coverage, convergence of the network, and also, again, reducing the amount of cabling that's needed primarily above the ceiling. But it does take that next logical step, as we've seen these switch vendors over the years acquire the wireless vendors or vice versa for a completely integrated solution, including wireless. We're now seeing that now in the passive optical LAN space.
Thank you very much. And thanks to all of our panelists. As I wrap it up today, we spent some bonus time going into the Q&A, and I hope you found today's content to be helpful. The Association of Passive Optical LAN, we are a collection of integrators, end users, vendors, and anybody who wants to see passive optical networks gain more attention because of the great benefits that we discussed today. Sustainability, there's a lot of things we didn't talk about, but the future certainly is not one where there will be less demand for the most precious thing on the planet, which is access to the internet. Broadband internet access is something that is vital and helps us across all of our businesses. And we members of the Association of Passive Optical LAN are dedicated exactly to that, on how to formulate solutions and make it accessible so that you, as folks delivering outstanding network experiences to your end users, have the information you need to take advantage of this latest technology, which might sound really new, but as all my panelists would agree, that this technology is proven and today runs terabit bandwidth networks and is perfectly suited, particularly as costs have changed, and it is just lower cost to deploy compared to a copper solution. So we'd encourage you to do that if you're interested in joining. We have a large variety of members, as I mentioned before, and this is always growing. You don't have to be a vendor or an integrator to join. You can be an end user and help influence how these technologies are developed as an industry and how we do better as an industry to be better stewards of our planet and have sustainable networks that deliver more bandwidth for less power, less weight, less material used, et cetera. And if you're interested, you can go to our website at applelandglobal.org/membership and look at some of the things that are there. But otherwise, we really appreciate you having joined us today. We don't have our next webinar scheduled yet, but watch for a post, an email registration link in the future. You can contact us there. And on behalf of my friends from Uber Data Networks, Nokia, and Corning, this is Mario Blandini from DZS. Wrapping up today's broadcast, we really appreciate your attention and we hope you found this time to have been well spent. Thanks again, folks, and we'll see you next time.